Have you figured it out yourself? Let's check if your answer is correct. So, to begin, we use the equation of conservation of momentum. m1v1 plus m2v2 is equal to m1 plus m2v final. Now, this is a bit of alteration because first, m1 has an initial velocity, but m2 does not have initial velocity. So the initial momentum of m2 is 0. Also, since the final momentum is the same, the final velocity for the two objects is the same because they collide each other and stick together. So they become one object with a mass of m1 plus m2. In this particular situation, since the second object does not have initial velocity, the final velocity of the two objects is equal to the final momentum of the two objects is equal to the initial momentum of the first moving object. Now let's get back to the math. Plug into the equation the numbers that we were given. We get 980 kilograms times V1 is equal to 980 kilograms plus 2,300 kilograms times V final. We also know that the kinetic friction constant is equal to 0.8. And using our F equals ma, we know that the force of friction is equal to the kinetic friction constant times the normal force, which is equal to the sum of the masses times the acceleration by gravity. Remember, this is a negative force because, as we defined earlier, the cars are moving. The skidding of the cars is being slowed down by the friction of the pavement. We get the force of friction is equal to negative 26,240 newtons. Using F equals ma, we find that the acceleration is equal to negative 8 meters per second squared. Now, using our kinematics equation, v initial squared plus 2 times acceleration times displacement equals v final squared. And we know that v initial squared is equal to 0. We can plug in the numbers. 2 times negative 8 meters per second squared, which we just found, times 2.6 meters, which is given in the problem. We get v final is equal to 6.45 meters per second. That's the final velocity for the two cars after they collided and stuck with each other. Now, plugging it back into our momentum equation, we can find the initial velocity of the first car. And the initial velocity of the first car is 21.58 meters per second. This is the velocity that the car had when it hit the second car.